All right, this is the video for Algebra 2, Unit 6, Lesson 3. And this lesson is focused on kind of beginning concept of factoring or some unique cases when it comes to factoring. When we talk about factoring, we're actually talking about the opposite of what we did in the previous lesson. So in the previous lesson, we were doing this right here. We were multiplying a number times different terms and expanding it so that it looked like this. And use another example here where we distributed 2x plus 3. And we got all the way down to here. And what factoring does, factoring takes the opposite approach. Factoring asks the question, how do I get from this final answer, 8x to the third, so on, and how do I go back to this? How do I get from here back to here? How do I undo all of this? And kind of how do I know where to start and do this? And so they actually just start with some basic patterns that we see frequently in factoring. So I'm going to kind of jump down here. They go through examples of each one. I would definitely recommend reading them. They show you kind of how we get from an expanded form to this shortened form right here. And then in the boxes, they kind of give you all of the different patterns. So these are the patterns that they're giving us, and I've already put those on the lecture notes. So let me go back here and show you. So these are the 5 main kind of factoring patterns that we're going to look at. So just for you to understand, we have 2 here that are what we call right here. These are called difference and sum of cubes. You'll notice that's a cube because that's what to the third is called in algebra, the cubed. So these are the difference and sum of cubes. Then we have one here that's called the difference of squares. Difference, again, refers to subtraction, and squares refers to the 2's. Then we have what we call perfect square trinomials. Perfect square trinomials are when we take the same term and we square it. We square the entire term. And then we have over on the other side of these equal signs, we have what you get when you actually factor these or multiply these out. So what we're going to be doing is we're going to be given something from this column over here, and we're going to be asked to get the resulting answer over here. In this case, A and B are just stand-ins for something else. So the first thing that they have you do, so I'm going to erase this real quick, and we'll come back to that in a second. What they have you do first is just ask you a few questions about the vocabulary. Let's go down. Okay, and then on number 4, you're just going to use that list I gave you to match up the correct expansion or the factored version with the original form here. So you're just going to pick the ones that go in the right places. So go ahead and do that. And then it actually asks you factor the polynomials. So I'm going to do a couple examples. I'm not going to do the ones that are here, but I'm going to do some examples that are similar to the examples that you have. So let me just jump here and let's see what we got. I'm going to actually scroll down. Nope, I can't. I'm doing a new drawing. There we go. So I'm going to go ahead and make up one that is similar to what you have. So let's say I had x to the third minus 64. Okay, so they want us to factor this. Okay, so what first thing that we have to do is we need to go back to our other drawing or our other little table, and that table is going to show us which one of these we're looking at. So you'll notice that in ours we have a cube, a number, and a subtraction sign. So this is a great example of the types of problems you're going to see. So the first thing that you need to recognize is that because of this to the third and this minus sign here, we are dealing with this first option right here, because this is cubed and a subtraction sign. You might be asking yourself, well, why is there a 64 there and not some other thing cubed? And that's actually the biggest part of what we have to start to understand with this type of factoring is you need to begin to recognize when the number here is actually a cube. So I'm going to kind of talk through how that works. And I will give you a list of common cubes and common squares on the lecture notes so you can use those. We know that 64 and this whole expression could be rewritten like this: x to the third minus 4 to the third. Now that's something that, again, you have to have kind of in your back pocket to know that 64 is actually a perfect cube. It is 4 times 4 times 4, or 4 to the third power. So now you can see how this looks like the pattern that we had in the previous one. So let's go back, and you see we have a to the third minus b to the third. And if we go to our next drawing, we see we have a to the third, b to the third. Okay, so then what is the pattern going to look like that I need to follow? Well, according to the information from the unit and from the other table, the pattern for a to the third minus b to the third is a minus b, and then a squared plus ab plus b squared. So this in green is the pattern that you have to follow. So what you're going to have to do is you're going to have to basically take x and put it everywhere there's an a, and 4 and put it everywhere there's a b. So let's go ahead and do that. So if I follow this pattern, I'm going to have x squared. I'm going to have an x there. And I'm going to go through and do my 4s. 4 is going to go here. 4 is going to go here, and we're going to have to deal with that middle term here in a second. And then 4 is going to go here. Okay, so the actual last step that we need to do is we actually need to simplify what we have here. So again, x to the third minus 64 is equal to, that first parentheses is fine, x minus 4, x squared. X times 4 needs to be rewritten as 4x, and 4 squared needs to be rewritten as 16. And so this would be the factored form of x to the third minus 64. I'm going to do one example of each. So let me move on, and let's do an example of x to the third plus. So let's say I have x to the third plus 125. Like, okay, that's a really big number. Hopefully you might be able to guess what that one is, but I'll go ahead and tell you. We need to recognize that x to the third plus 125 is the same as x to the third plus 5 to the third. So that 5 and that x are going to be the a and the b of our answer, right? So if we're going to follow the a to the third plus b to the third pattern, this is what we're going to be using. So looking at the pattern says this. The pattern says to do a plus b, parentheses, a squared minus ab plus b squared. Okay, very similar to the other one, but we have a different arrangement of signs. So let's go in and let's do x's wherever there's an a, 5's wherever there's a b. So x plus 5. A squared is going to be x squared minus ab. 5 times x is 5x. And then b squared is 5 squared. 5 squared is 25. And so we're actually done. So that is the correct simplification or factoring of x to the third plus 125. All right, so we're going to keep moving. I want you to see an example of each one. I'll, of course, post these in the lecture notes. So let's say I have, and then I'm going to do an example of each, and then I'll show you some of the kind of unique situations you might come across. So let's say I have x squared minus 9. Okay, now right away, you should see this 2 here is a squared. So we're no longer dealing with the difference of cubes. We're dealing with the difference of squares, which is going to be right here. A squared minus b squared equals a minus b, a plus b. So this one's a little bit easier, actually. It's less writing. But we need to recognize, of course, that we have a 9 here, which is going to mean a different, it's not going to be, it's not already set up for us as a squared. So again, we're using the pattern for a squared minus b squared. And the reason we're doing that is because we have x squared minus, and then it's 3. 3 squared is 9. So these are the a and the b term that I'm using in my example. So like I said, the way the pattern works is it is a minus b, a plus b. So x is a, 3 is b. So let's go through and follow the same pattern. X minus 3, x plus 3. And so that's the final answer. Okay, so that's the difference of squares. Let's keep going. Let's say I have the following. Let's do a different letter just to mix it up. So let's say I have y plus 7 squared. Okay, so I've got a different situation again. I'm now looking at this right here, a plus b squared. And then I have my pattern right here. So let's go back over to our other drawing. Scroll all the way down, sorry about that. Y plus 7 squared. All right, so again, we're using the a plus b squared version. And so let's look at what this is. So again, y is going to be a, and 7 is going to be b. So we're going to follow through in the pattern. So the pattern is a squared plus 2ab plus b squared. So then I'm going to run through. I'm going to put a y where there's an a, put a 7 wherever there's a b. So we're going to get y squared plus 2ab. So 2 times 7 is 14 times y is 14y. So make sure you understood that it's 2 times 7 times y. 2 times 7 is 14, and then the y. And then b squared is 7 squared. 7 times 7 is 49. And again, that's the final answer. I think the point is pretty well taken, so I'm going to actually not do the final one. It's very similar to the one we just did. It's just minus. It changes the pattern. But I do want to talk about what happens when a cube or a square has a little bit of a different setup. So what I mean is this. Sometimes let's say we do sum of cubes. Let's say your sum of cubes looks like this. I'll do 27 x to the third minus 64. Okay, so right away you'll recognize like, okay, we have a third here, so it's going to be difference of cubes, but there's this 27 up here in the front, and this is kind of making things a little bit different than the first ones that we did. But we're going to follow the same exact kind of process and idea that we did in the previous problems. So what I mean by that is in the same way that we looked for what to the third power made 64, we need to ask what to the third power gives me 27x to the third. And you can kind of deal with these separately. So we're going to deal with the 27 and we're going to deal with the x to the third. Now the x is easy because x to the third is x. But then it's like, what is the cube of 27, and it's 3 because 3 times 3 times 3 is 27. So we're going to put a 3 right there because 3 to the third is 27. And then we already know 64. We did that in the previous problem, and that's going to be 8. So it's a little bit different because now there's this coefficient. That's what we call that in algebra. There's this coefficient in front of the x, but that's okay. We can still follow the same pattern. And the pattern for difference of cubes is as follows. A minus b, a squared plus ab plus b squared. So we're going to follow this through. We're going to put 3x everywhere there's an a, and we're going to put 8 wherever there's a b. So we're going to do it right now. So a is going to be 3x minus 8, 3x, 8. Okay, now 3x squared plus 3x times 8 plus 8 squared. So you can see it's a little bit more complicated because of these coefficients. We have to deal with these parts right here. So we're going to have another step of working everything out. So we have 3x minus 8. 3x squared is going to be 3 squared x squared. So 3 squared is 9. 9x squared. 3 squared is 9. X squared is x squared. 3x times 8 is 24x. 8 squared is 64. And I made a mistake. So I'm going to go, and I'm really sorry about this. I'm going to erase this. This all along should have been a 4, not an 8. So I'm sorry about that. So let me erase this. These should all be 4s. Really sorry about that, everybody. Hopefully that didn't mess you up too much. You're probably thinking, what are you doing, Mr. Matthews? That's wrong. So we're going to go back and let's redo this second part. Even I make mistakes. All right. So this should be a 4. This still is 9x squared. Now this changes. 3x times 4 is 12x. And then 4 squared is 16. And that's what we have there. Now the key idea here is being able to convert something like this into its cube form or whatever like that. So hopefully that one will help you with the problems you see in lesson 3. That should get you everything you need for numbers 5 and number 6. And then I'm going to pause the video and do a part 2 for the rest of the